This is the lesson for Chapter 9, Section 2, called Quadratic Functions, day number 1. And what we saw on the last section is we had to graph quadratics. And all our quadratics that we graphed were in this form, y equals ax squared plus c, where we had a quadratic where we had an x, or input to the second power. A was the number out in front of x squared, and c is a constant. It didn't have an x term, and that's what we see on all of these problems. And again, it could be y or it could be that function of x notation. And so what we ended up noticing is that all of the vertices were always on the y-axis. It's every single time. And so we ended up seeing that, like for instance here, this y, we had to match these, and it says f of x is x squared minus 1. So we knew that this was the y-intercept. The c value, when we set x equal to 0, we have the y-intercept. So right away I know b is the answer for 34 just by looking at it. I also know that it is because it's a positive x squared. When it's positive x squared, I know it opens up. So this one opens up. And when it's a negative x squared like this, it opens down. But I have two of them that open down. So I can go to the y-intercept right there, and I notice that that's positive 8. Well, positive 8 looks like this is it right here, plus it's very narrow. And so with that coefficient in front of the x squared term, that is, the absolute value of it is quite large, bigger than 1. It makes it narrow, and it opens down. And so let's take a look at the last one here. I know, again, 35, or A, goes with 35. And this one has to go with C, not only because it's left over, but because look at the y-intercept. It's positive 5. Again, that starts up 5 spaces. And I know it opens down, and I know it's wide. It's wide because this is close to 0. So closer to 0. And so when it's close to 0, that tells me it opens. It's going to end up being wider. And so notice again, all those vertices were on the y-axis. Well, now we're not going to see that. And what's going to be different is we're going to add in a term between the x squared and the c terms. So let's take a look at what we'll see on tonight's assignment. So now we've got equations in this form, y equals ax squared plus bx plus c. And so we still have that y-intercept. This is my y-intercept here. And I also see that on all of these y-intercepts, and there's actually just one of them, and all of them have a y-intercept of 0. And the reason is that on all of these graphs, we could add on 0 here, and look, that's where the y-intercept is. It's just crossing right at the origin. But what we don't know is where the vertex is. This time, the y-intercept is not at the vertex. It's down here. And so what we want to do is we want to find this axis of symmetry. That's going to help us out. That's going to be the x component of that vertex. So what they're doing is they're comparing these equations. And notice whenever we have an x term, and that has the coefficient b in front of it, that's going to modify where that axis of symmetry is. It's going to move the parabola left or right. And so what they did here is they looked at the a and the b term. So here's the b term, here's the a term, and they divided it. Notice when they divide the 2 over 2, they get 1. And notice where this axis of symmetry is. It's at negative 1/2. So they got a 1 here, and it's negative 1/2. If we look at the next one, the b over a here is 2. And notice that we have a x value, axis of symmetry is negative 1, which is negative 2 over 2. And same thing here, our b over a here was 6 over 2, which made 3. And our axis of symmetry was negative 3 over 2. It's just right in between negative 1 and negative 2. And so what they saw was that the axis of symmetry is negative 1/2 times by b over a, and that's going to end up being our formula that we're going to end up using to help us find that axis of symmetry. So this is the key formula we're going to end up using, negative b over 2a. So let's practice using that. And the next type of problem here, again, we'll go for the key concept. So when we've got a quadratic in the standard form, ax squared plus bx plus c, where a is not 0, so that if it can't be 0, otherwise it would not be a quadratic, the axis of symmetry, the line for that axis of symmetry, is going to end up being x equals negative b over 2a. It's going to be the x component, the x coordinate of the vertex. And so what we're asked to try to find is the axis of symmetry and then the coordinates of the vertex. And so the first thing to do is we've got to find that negative b over 2a. So we're going to find the axis of symmetry, negative b over 2a. So let's go ahead and figure out what is our b term, what's a. Well, remember, the formula goes this way. Y equals ax squared plus bx plus c. So if you're missing a term, that means it's 0. So a equals 4, b equals 0. My c value, c is negative 2, but I don't need this number right now for this formula. So when I go ahead and substitute it in, I have 0 over 2 times by 4, and the opposite of that. Well, 0 over 8 is just 0, so x equals 0. See, that's what we had before. Negative 2 would be the y-intercept, is where that would cross. Well, now I know what the axis of symmetry is. It's x equals 0, and this is the axis of symmetry. And so now I want to find out what that vertex is. So what I'm going to do is I'm going to take that axis of symmetry, 0, and plug it in for x to find out what y is. So I have y equals 4, but in place of x I put 0 squared minus 2. So I go ahead and do that work. This makes 0 minus 2 makes negative 2. So my vertex, the coordinates for the vertex are 0, negative 2. And that's what we have there. So let's take a look at one that has all three numbers here. And the first thing I'm going to do is write down what my a term is. Negative 1, it's the number out in front of x squared. You can always put a 1 in between the negative sign and the x there. And then the b term is positive 4. C is negative 6, but we don't need the c term right now. All we need are these two terms. And so I'm going to plug them into my formula, which goes negative b over 2a. So b is 4, so it's going to be the opposite of 4 over 2 times by negative 1, which makes negative 4 over negative 2, which makes 2. And so my x value is 2. So this is the axis of symmetry. And then once I've got that, I can move on to my vertex. Again, that was a positive term. I put a little mark next to it, makes it look like a negative, so I'm going to fix that real quick. And so from there, I can go ahead and substitute into 2 in for these x's. So negative 1 times by 2 squared plus 4 times 2 minus 6. So here's where evaluating expressions came in, and why we practiced those earlier on, because we have to remember order of operation. So the exponents come first, multiplication comes before addition, and this is what I've got, negative 4 plus 8 minus 6. And so a rule with this is that whenever we're plugging in the axis of symmetry into our equation, we always end up with this situation where we're going to end up having a negative x squared term, or one term will be negative, one will be positive, and then these two will always end up subtracting to make one of the values, the absolute value of one of the values, in this case 4. So 4 minus 6 makes negative 2, so y equals negative 2. So our vertex is 2 comma negative 2. And that is the vertex. Let's take a look at the last one here. So again, I'm going to find my a term, which is negative 6, b, which is negative 8. And so I go ahead and substitute into my formula. Again, I don't need the c term here. So x equals the opposite of b, so opposite of negative 8 all over 2 times by negative 6. And so opposite of negative 8 is positive 8 over negative 12. So it's going to be a negative number. I'm going to reduce the fraction, take out that common factor, and that's going to leave me with a negative 2/3. So that's my axis of symmetry. X equals negative 2/3, and that's the axis of symmetry. So the next item is to substitute in. So I'm going to find out what y is. So it's negative 6 times by negative 2/3 squared, and then minus 8 times by negative 2/3, and then plus 10. So when I do this, here's where fractions come into handy. We need to know how to do these, because this would give me a repeating decimal, and those are tough to deal with. So fractions aren't so bad. Just multiplying two integers together, just one's on top of a fraction bar, one's on the bottom. So it ends up making 4/9, and I've got to multiply that by negative 6. So I'm going to do a little cross-canceling here. This becomes a 2, this is a 3, and so I end up with negative 8/3. Okay, so over here, I end up having two negative signs, And so they're going to cancel out, and that's going to make a positive 16/3. And so I'll have positive 16/3. And over here, I still have that plus 10. So again, you notice that these are opposite signs, and one's kind of double the other if you think of the absolute value of them. And so this ends up making 8/3. And so I need to add 10. And so when I do that, I can go ahead and do one of two things. I can either change this to a mixed number now and add, or I could change this to an improper fraction. I'm going to choose to change this to a mixed number. And so I'll do the work up here. So that's going to be 2 2/3 is what 8/3 is, plus 10 gives me 12 2/3. And so that's going to be the y component of the vertex. So the vertex, again, this was y. The vertex is, and then where's my x value? There it is, negative 2/3, comma, 12 2/3. And that's what we end up seeing. So those are the types of problems that we're going to see on tonight's assignment. Good luck.